So we've been called out to take a look at a commercial drainage project, and I want to walk you through what the solution is. So I'm going to start kind of at the end of this line. On this building, we've got a large commercial building. We have 4 points on this building, which really technically isn't enough. So a lot of water is coming out at 2 points on the left side of the building and 2 points on the right side of the building through what's called a scupper, which is basically a roof drain that will discharge towards the top, and this water will rush out of the top of the building onto the ground like a waterfall. Once that water flows down this way by gravity on top of the surface, there is a large drain basin existing in the ground. That drain basin is right about here, about 10 feet behind me, and that drain basin discharges with a 6-inch corrugated pipe that only comes partially the way down the hill, and it has to run over all of this dirt and gravel area before it hits the parking lot, which means it's going to carry a lot of sediment in this water. It's going to carry a lot of debris. It's never going to allow anything green to grow here, and that's why you see all the rocks on the surface, because that's just a sign of more erosion and sediment and discharge from this pipe. So step one in this process is actually step 5, or I should say is down the line. When we end this system, we're going to take out this corrugated pipe, upgrade it to a 6-inch PVC pipe. We're going to take it underground through this area, and we're going to discharge through 2 points at the curb with 4-inch PVC. And I know I just said 6-inch. I have to use 4-inch at the discharge because the curb is only 4 inches thick, so a 6-inch pipe won't fit through the curb. So when I get towards the end, I'm going to split that 6-inch pipe use a Y fitting, split it into 2 4-inch discharge lines. That is going to allow the water to stop running so heavily on the surface, which is going to in turn allow me to establish some ground cover, some grass seed, some fescue seed, and some wheat straw. Here is the drain that I talked about that is collecting surface water. Over time, due to the age of the building and the movement of the land, this drain is not collecting with very good efficiency. There's a lot of water that's bypassing the drain or missing the drain, and in some cases, as we get towards the back of the building, even falling off in the wrong direction. So there's an existing 6-inch PVC inlet pipe coming in through here that's collecting from several interior drains and surface drains. We're going to be attaching into that 6-inch pipe. That 6-inch pipe is already routed below grade, so that does save us a little bit of work and a little bit of trouble. But after we're done tying in these new scuppers and downspouts, we're going to regrade the entire side of the building to create a swaled area, just a nice shallow swale down this area, and then we're going to vegetate this with fescue seed and wheat straw. I don't expect that the fescue seed is going to perform fantastic right in the center of this swale because water is going to be moving down it, but it will be providing function, because right now water is allowed to collect and run off on a width of this area is probably 14 to 16 feet wide. We're going to be channeling that to an area that's about 4 feet wide to give it more direction and to flow directly to that drain basin. So our first scupper is up here on the building, and you can imagine this is 15 feet, 16 feet off the ground, and this is going to just allow water to pour over here like a waterfall, and it's rutting out right in front of this gas meter. So the general contractor is going to be installing downspouts and interior drains that come out. Our job is going to be to bring in 6-inch pipes to this location underground and tie into another existing 6-inch pipe, which is already below the surface. So that's location number 1 on the left side of the building. Here's our 6-inch pipe. This area right here is provided as a clean out for that pipe. And here's our second scupper up here on the roof towards the back left side of the building, and that is where more water is rutting this area out, and you can just see just from the pounding of the water coming out that this drain box is really relatively useless at this point in this location. So we're going to eliminate that direct pipe everything. So as we get to the back left side of the building, one thing that you can see is water, which should ideally be flowing all towards the front from the area that we just walked past, is actually, just because of over time how the grade has changed due to water flow, it's actually flowing backwards, back and around towards the back of the building, which is not an ideal situation, because once it gets to the back left side of this building, there was a riverbed that was originally put in to capture water and make it flow, which it probably did, but you can see how much higher these rocks are now to the ground. They're probably 4 or 5, some areas 6 inches higher than the adjacent ground area, and that's just because of water runoff pushing this dirt over time and eroding it away. So what we're going to do is reestablish this grade. We're going to lift it up, we're going to vegetate it with fescue seed and wheat straw, and we're going to regrade this area so now everything is going to flow back toward the front of the building. So that is going to correct this situation. It's a long-term solution. PVC pipes are not going to have to be cleaned very often. They're not very easy to clog, so they're going to stay free running. If they do need to be cleaned, there'll be clean out points shorter than 100 feet, so a plumber snake will go in there very easily, but we don't expect that there's going to be very high maintenance on this. And we do expect that this will be a permanent solution. So we're going to take a walk over to the right side of the building, and I'll pick it up there. Okay, I told you I was going to the right side of the building. That was only partially true. I am headed there, but I want to talk about this back concrete area. This is sort of a nice gathering, recreation, outdoor living area for the employees at this company, and it looks really nice. Got a nice stone wall on the inside, but one of the things is this stone wall is actually trapping water, so it's almost becoming a swimming pool when it rains. There is a surface drain basin right about there, and it's kind of like a pool, something you would see near a swimming pool. It's got a long channel drain, probably about 16 feet long by 4 inches wide, which would work great, but the channel drain is completely clogged. And I'm looking at the elevations, and I see that the pipe discharges out this side, and there is very little pitch. So I don't expect that even if we were to clean this channel drain completely, that it would still function all that great. So here's what I'd like to do. I'd like to go into the back of this wall, and I'm judging this by eye. At some point I will have to shoot the level with a laser, but it appears to me that along the back of this wall, if I had weep holes that would allow this water to come out, and when I say weep holes on something like this, it'd probably be 2-inch holes that I would drill along this wall. On this side of the wall, I would probably have 3 to 4 2-inch holes, and then perhaps 1 or 2 on the back portion of the wall. If I had these 2-inch holes, it would allow the water to come through, drain very quickly after a rainstorm, and then I could collect the water on the outside through a drain basin that would have the correct pitch and would be very easy to clean. So that'll be one of the plans that we have, is to drill these 2-inch holes and then to sleeve them so we can allow the water to drain out of this area. So now I'm going to go to the right side of the building and I'll pick up from there. Okay, I am back on the right side of the building, and I want to kind of give you a shot of this building. Again, we're dealing with 2 scuppers, one at the top here and one at the top towards the front. Another drain basin here that is rutting out, same situation as before. So the solution for this will be, again, the general contractor will run a downspout. We will connect in with a 6-inch PVC pipe. That 6-inch PVC pipe is going to run towards here, but I've got an obstacle. I've got this sidewalk in the way. And on the opposite end of this, let me back up. My choices here are I can discharge the water right here on the inside of the sidewalk through what they call a 4-inch pop-up emitter, which has a spring and a lid. And when the water line fills up, it creates pressure on the spring, pushes it up, and allows the water to discharge in a 360-degree radius. Supposed to be at a slower velocity, although they can still put out quite a bit of water. The problem is, once I discharge it on the sidewalk, it's going to hit this wall of ivy, and it's going to kind of dam up again and could create future problems. So what I think the most permanent solution for this area is will actually be to saw cut this sidewalk and route the pipe underground. Let's take it out about 3 or 4 feet into this natural wooded area to allow the water to discharge, where it's not going to create a problem for people and it's not going to get in the way, and then we'll just pour a little bit of concrete to fix it all up when we are done. So now I'm walking to the front right side of the building, and as I get over here, I can see in this curb is actually an existing 4-inch discharge pipe right here in this curve. So what we're going to be doing again is we're going to be taking a 6-inch PVC pipe underground, and we're going to discharge it through 2 4-inch PVC pipes that are in this curb, and that is the solution to the project.